All right, you guys, welcome to our full stack YouTube clone tutorial that we're going to be doing. And we're going to be pretty much showing you how to design your software with a real life example. I think YouTube is an amazing example to use for this course. And I also have other reasons for, choosing YouTube of all places. But before we get into the question of this particular lecture, what is a microservice? What I'm going to do is I'm just going to type in microservice on Indeed and let's see what pops up. So we got over 45,000 jobs that have something to do with a microservice. So um, this is a very hot in demand skill. This is something that can take you very far. If you are interested in going into technology, whether you're interested in going into back end or front end, it can do a lot for you. Now we're going to get more specific and let's just put Node.js next to the microservice query and let's see what pops up next. This gives us about 2,000 results and this helps us to kind of narrow down what we're looking for. So if we just go to a random example, let's just go to this senior software engineer full stack, which is based in San Francisco. They're paying $110,000 to $165,000 per year. And some of the skills that they want include microservices. So if you read the actual responsibilities of what they want you to be able to design, implement, validate, deploy, troubleshoot, maintain, and upgrade your software. And the second thing that they listed would be backend software development for web scale microservices and database. What does that even mean? So that's why I decided to do this video, because you have to understand what a microservice is in order to be effective, whether you are a front-end developer, a QA person, or something else. So let me share this diagram with you right now. Sorry, this is not the right one. It's actually the other one. It's going to be, should be this one. Wow, it keeps going to this one. Sorry, 1 second. You gotta love StreamYard and their sharing tab issues. So, okay. So we are looking at some diagrams that I put together to kind of show you how we used to build software applications. And this is a high level overview, because if you don't understand this, then you won't be able to understand how to become a senior engineer or how to move up in a company. So the way that we used to build software applications are very monolithic. So we used to have a user interface, right, which in modern day terms will probably be some sort of React based application, some sort of Angular based application, or Vue.js based application. And we have a giant API, which we route all of our requests and authentication and middleware to. And that API then reaches out to our database and gets the data that we need to get. And then it passes the data back to the API, and then that gets passed back to the user. So this is what we call a monolithic approach to software design and development. So I'm going to give you an example right now, like a monolithic server in, modern day terms. So let's say we had YouTube, and YouTube just started, and you could only do a couple of things with YouTube. You could upload a video, you could start a live stream, you could comment, those main things. So to be able to do these things, you would have to have some sort of authentication, right? Authentication just means you have access or specific permissions to be able to do something inside an application. So to upload a video to YouTube, of course, you would have to be authenticated and verified. Same thing with live streaming and commenting. And this authentication token, right, or whatever way you have it set up, is usually set up as some sort of JSON web token, will then get passed into your router when you make that request. And then you make that request to either post something to your database or to get something from your database. And this was all done in one giant API, one giant file that makes all of your requests, that does all of the uploading and managing live streams and commenting in chat rooms. So you can imagine that this can get very complex. And once you get to a level like a company like YouTube, you can start to need to scale. And that's what YouTube has been doing for the past few years. So it's Facebook, so it's Twitter, so it's Instagram. So the important thing to understand when we talk about a monolith, when we talk about how we used to do things, each monolith will contain these four things: routing, right? So for example, slash youtube.com/upload, right? Middleware is what's going to do your authentication, right? In between your routing to make sure that people have access to be able to do certain things. Your business logic would be your server side logic, which would be, just think about what the business cares about. The business cares about, um, let's say, how many users were able to upload a video today, what speed they were able to do it, people that were sending donations, how were they able to make money off of their application. So that's the key part of, anything dealing with backend is strictly business logic as well. And then also each monolith inside your application would have access to your database. And all of these things would implement all features of our app, right, in one giant container. You could look at it like that. Now, there are downsides to the monolithic approach. So, we're going to get into more detail about this in the future. But for now, just know that when you have many, many requests being made to different databases and different endpoints inside your application, it's very easy to have what we call a memory leak. And this is what happens when, let's say, you try to request a video on YouTube and it's saying, hey, we can't find the video, even though you know that the video is public and it's already been uploaded. So that's one example. Number two is it's hard to scale. So because you have one large giant database with multiple different tables, with multiple different properties of different objects or different data types, you could say, it can be hard to update that database if for some reason you need to add a new feature and you need to add new things, and you're always adding new things as a software engineer. So your database schema is likely to change at some point. So it's hard to scale. And number three is there's a single point of failure. So if you have a monolithic application that has one API that makes all of your requests and gets all of your business logic handled to one single database, if for some reason that database goes offline, then your entire application has a single point of failure. And we'll talk more about good architecture, the AWS architectural principles. But for now, just know that it's a single point of failure. And then number four, what happens when people want to migrate to the cloud? What happens when people want to migrate from EC2 instances to, let's say, Lambda functions? It can be kind of hard to refactor an application if you're talking about a company as big as YouTube. So it's hard to refactor. There's memory issues. It's hard to scale, and there's a single point of failure. So, what is the solution to these problems? Well, the solution to these problems is called a microservice. So, let's scroll up. So, a microservice contains the routing, the middleware, the business logic, the database access in one service. But here's the key difference: we're not trying to implement every single feature of our app with a microservice. We're only trying to implement one thing. And so this is kind of like a reflection of real life because you can only focus on doing one thing at a time. And why would our architecture have a different form of logic when we know that we can perform better when we just have everything kind of separated into smaller pieces? And this makes it a lot easier for you to figure out problems inside your application, for you to figure out where memory's leaking, for you to scale your application or update your database. You won't have to update a big giant database. You just have to update whatever database is using that particular service. And so here's an example that I created. So this is what a typical microservice approach will look like. So we have several services, all right? And in the case of YouTube, we have an upload service, we have a comment service, we have a chat service so people can chat inside of a Premiere or a live stream. And we also have a live stream feature, which allows people to create live streams. And so instead of having all of these features implemented in one giant monolith, each service has its own auth and middleware. Each service has its own routing setup, and each service has its own database. So there's one database per service. So the comments database is called comments, the chat database is called chats, and the live streams database is called live streams. So with this approach, we are able to solve many, many problems and also increase our efficiency and proficiency as engineers to solve problems faster, to improve performance, and to scale, because every company wants to grow, every company wants to scale and become bigger and bigger once they reach a new level. So this is just a quick overview of the downsides to the monolithic approach and what is a microservice. Now that you understand that a microservice contains everything needed to implement one feature of our app, we will now get into the two different ways that we can communicate through our microservices, because our microservices need to communicate with each other now that they're separated, and they also need to communicate with our feature, which we are calling our UI. So with that being said, I will see you guys in the next video where we will discuss async versus sync communication styles with microservices.